Hello everyone, welcome to session 14 of chapter 2, Solvents. In this session, we are going to discuss solutions of alkali metals in liquid ammonia. So what are alkali metals? Yes, they are 1s block elements. Other than hydrogen, which is an exception, we have lithium, sodium, potassium, rubidium, cesium and francium. Okay, when these alkali metals are dissolved in ammonia, what is going to happen? In general, you all know when metal is dissolved in solvents, in water, say for example, when you add sodium to water, what happens? Yeah, I don't want you to do it, but when you add sodium into water, hydrogen gas will be liberated. Hydrogen gas will be liberated. Hence, sodium will be converted into sodium hydroxide and hydrogen gas evolution occurs. This is the reaction of alkali metals in water. Now let us see what will happen to alkali metals in liquid ammonia. A similar kind of reaction occurs. Say here, ammonia reacts with metal to give hydrogen gas, metal cation and amide anion. Okay. So let us read this. A remarkable feature of alkali metals is their ability to dissolve reversibly. Okay, this is a reversible reaction in liquid ammonia. Just as in their reactions with water, reacting alkali metals with liquid ammonia eventually produces hydrogen gas and the metal salt of the conjugate base of the solvent. In this case, the amide ion rather than hydroxide ion. There is one more very nice thing about this particular reaction. When you add sodium to liquid ammonia, the solution turns blue here. Blue. What is happening is, blue is the indication of free electrons. Check here, free electrons. See here, where the designation refers to ammonium solution analogous to the used in aqueous solutions. Without a catalyst, the reaction in above equation tends to be rather slow. In many cases, the alkali metal amide salt is not very soluble in liquid ammonia and precipitates. But when dissolved in very concentrated solutions of alkali metal are produced. 1 mole of cesium, for example, will dissolve in 53 ml of liquid ammonia. The pure metal is easily recovered when the ammonia evaporates. So it is like this. Solution of alkali metals in liquid ammonia are intensely colored and good conductors of electricity due to the presence of solvated electrons. Check here. Electrons, free electrons are liberated. And these free electrons get solvated, and hence they become blue in color, okay, which are not attached to single atoms. A solvated electron is loosely associated with a cavity in ammonia solvent that is stabilized by hydrogen bonds. Alkali metal liquid ammonia solutions of about 3 molar or less are deep blue and conduct electricity about 10 times better than aqueous NaCl solution because of the high mobility of the solvated electrons. As the concentration of metal increases above 3 molar, the color changes to metallic bronze or gold and the conductivity increases to the value comparable with that of pure liquid metals. So what has happened here? As you dissolve the alkali metal in ammonia, see, alkali becomes Na plus. We have free electrons liberated. These electrons get surrounded by the solvent. Electron gets solvated. So those electrons which are solvated are isolated and hence they become good conductors. Okay, the conductivity of the solution increases. It will become a very good reducing agent. And as you go on increasing the concentration, its conductivity will be equal to that of pure liquid metals. So Na, which is Na solvated, gives you Na plus and electrons. Okay, so this is ammoniated cation and the overall reaction, this is ammoniated electron. Overall reaction is Na plus becomes ammoniated cation as well as ammoniated electron. So this is what happens when solutions of alkali metals are prepared using liquid ammonia. I would like to show you a video. Okay, so a video wherein it is quite visible. The solution turns blue in color. Okay, let us see that.
Here, and we're getting a blue color. And what's taking place here? The electron is coming away from the sodium metal, and it's just staying.
See here, sodium has been added to ammonia. Electron comes, so there is hydrogen gas evolution, which is occurring. Okay, and when you leave it for a little more time, it's going to turn blue in color.
Forming sodium ions, Na+, and we're losing this outermost electron, and this is giving rise to the blue color that we're seeing. It should eventually turn into a really deep blue color all through this solution. So just keep it, you can certainly see it at the bottom here now, all the wisps of color coming off of this. So just keep an eye on that, and you should see it all goes completely blue after a short time. So there we're allowing the electron to come away. This is this outermost electron, and it doesn't matter which metal we're using here. Any of these would give rise to this same blue color, thought to be a solvated electron moving around in the ammonia there.
Okay, so we have seen through this video that what happens when you have sodium or any alkali metal dissolved in liquid ammonia. Okay, I hope you have understood this concept. So in this particular session, we have seen solutions of alkali metals in liquid ammonia. Thank you.